Welcome back to the third video in this Intro to R Basics video series. In this video, we are going to be talking about data frames. Data frames are a convenient way to store variables together into a data set, and we're going to start off right away with an example. So again, remember, we're building good habits, we're commenting our code, working with data frames. So here, I want to create a data frame where one column has the student name and the second column has the number of cups of coffee that they drink per day. So student and coffee data set. I first need to create these vectors, and we learned about this in the last video. So I'm naming the vector of student names very like as it should be named, just student. So my student vector is going to be student A, student B, student C, and student D. Now you're noticing that I put these letters inside quotations. This is because these are our character values. If our vector has character entries, then these need to be inside quotations. If they were numbers, we don't need to add the quotations, but because they are characters, we put them inside quotations so R knows the type of class that this vector has. Next, we have coffee per day. And I'm just going to make these numbers up. So student A drinks 0, maybe student B drinks 1, student C also drinks 0, and then student D needs a lot of caffeine to get through the day. So they have 3 coffees a day. Now, I'm going to run these. Run. And we see that they showed up in our environment. Now, to create the data frame, we use the function data.frame, and I'm going to name it df, which stands for data frame. So data.frame. And again, if you ever want more information on how to use a function, you just put question mark, name of the function, and it'll show up in the help window. So in my data frame, my first vector, I want that to be the student name, and the second, I want that to be coffee per day. So when I run this, we see that in my environment, now it has 2 different sections. The first one is data, and the second one is values. And this will include any sort of just one value, a vector, a matrix. I also want to point out that the environment also shows the class of each value. So here we have a bunch of numerical vectors, but here CHR stands for character, and that's the student vector that we created. If we go up to data and expand that, we can see that inside of DF, which is what we named our data frame, there are 2 vectors, student and coffee per day, and it tells us what the class of that vector is and what the entries in that vector is. And so these variables with their entries make up our larger data frame. Like I said, a data frame is a very convenient way to store variables together in a data set. If I want to see what it looks like in my console, I just write the name of my object, run it, and it shows up in the console down here. Just like we can extract elements from a vector using the square brackets, we can do the exact same thing with a data frame, but now we have 2 different dimensions. We have the number of rows and the number of columns. So we need to specify 2 different numbers when we are extracting an element. So say we want to extract the entry in the first row, second column. What we would do is we would extract from the first row and the second column. And that entry is 0. We can confirm that just by looking at df. So first row, second column, we have that value is 0. If we want to extract the entire second row, we would again use our square brackets. We want the second row, comma, and we keep that second entry in the square brackets blank. And that signifies that we want all the columns. So when we extract the second row, that's exactly what we get, the second row. And we can do the exact same thing with the second column. We keep the row blank because we want all the rows, comma, we want the second column, and we get the values in the second column. Another way that we can extract columns, because in your data frame, each column is going to have a name, is we can use a $sign. So we have the name of our data frame, df, and if I put this $sign, immediately I am prompted with the 2 columns that we have in our data frame. So I want the coffee per day. I run that, and I get the second column. So these are all the entries in coffee per day. These are the 2 ways that we can extract columns. This is how we extract rows. And if we want a single element, we need to have values for the row and for the column. Now, there are also other elements of a data frame that might be of interest sometimes. If we want to know the number of rows in your data frame, we can use the nRow function. Similarly, we can use the ncol function for the number of columns. And if we want the dimensions, so the number of rows and the number of columns of our data frame, we can use the dim function. So dim 4 and 2. Number of rows is 4, number of columns is 2. So we just created a data frame, but there are actually a ton of data sets that are preloaded into base R, and even more packages that also have data sets, but of course we would have to install these packages first. If you want to see what data sets are in base R, you're just going to write data and put parentheses and run this. And immediately a new window will pop up with all of the data sets that are in base R with a very short description. And earlier in video 1, we loaded the package dplyr, and there are actually some data sets in that package as well. But these ones up here, these are all just in base R. So once you download R, these are automatically included. The one that we're going to be looking at is the iris dataset, which is Edgar Anderson's iris dataset looking at flowers. There are 3 species of flowers, Setosa, Varicolor, and I cannot remember the last one, but we are going to look at the dataset and figure out what that 3rd species is. So we don't need to install anything or do anything. We can immediately just start calling upon this dataset because it's already preloaded into R. So preloaded datasets, we're using the iris dataset. And first, I want to get a sense of what this looks like. So if I want to see the first 5 entries of this dataset, I can use the head function. So this data set, we can see that it has 1, 2, 3, 4, 5 variables. We're looking at the length and width of the sepal, the length and width of the petal, and the species. Similarly, I can look at the last 5 entries of the data set, and that's the third species, Virginica. So there's Setosa, Virginica, and Varicolor. And we notice that the last 5, that index is 150. So just by looking at this, we know that there are 150 entries in this data set, but we can also find that using the dimension function. So here we see that there are 150 rows and 5 variables. Again, we need to comment. So these are the first 5 entries, the last 5 entries, and this one, dimension. Okay. If we want to extract, we can do the exact same thing. So say I just want to extract all of the species. I just want that, that variable. When I extract that, we can see, oh, I've been pronouncing it wrong this whole time. It's versicolor, not varicolor. Anyway, so this pops up like this. And again, we see that on the left-hand side, we have the index of that first entry in each row. So we have our data set. Say we want to extract specific observational units, so specific rows. And say the first one is we only want to extract those rows that have the species Setosa. So what I would do is we're going to use the which function, this one. So extract rows from iris that have species Setosa. So again, we're going to use our square brackets. We're extracting from our data set iris, and we want the rows which have species equal to Setosa. So which the species is equal to the character Setosa. Those are the rows that we want. In terms of the columns, we want all the columns. When we do that, we get a data frame that has 50 rows. And these rows are only those that have the species Setosa. We're extracting in the exact same way, but instead of actually putting a number in there or a single object in there, we're using a function to extract. We can also make this a little bit more complicated. So extract rows from iris that have species Setosa and have sepal length greater than 5. So to do that, we're going to use the operator and. We want the rows which the species is equal to Setosa and the sepal length is greater than 5. Oh, okay. This is a good learning moment. So I put which the species is equal to Setosa and the sepal length is greater than 5, and I'm trying to extract this, but I'm just putting one value in my square brackets when I'm trying to extract something from a data frame. My issue here was that I'm only extracting one value when in the data frame we have rows and we have columns. So these are all the rows that I want, but I need to specify which columns I want as well. So I just forgot a column or a comma here. So all of the entries which did not have species Setosa and have a sepal length that is less than 5 were removed. And what we're left with is these indices. from the dataset. Finally, we can make this a little more complicated using another operator, the OR operator. And what we want are the rows from iris that have species setosa or versicolor and have sepal length greater than 5. The way that we do this, the OR operator is just going to be the vertical line. So we want the rows which the iris species equals setosa, or the iris species equals versicolor. We're going to put this in brackets because we want that to happen first. And the sepal length is greater than 5. Those are the rows that I want. I want all the columns. And when we do that, what we get is a data set that either has species setosa or versicolor, and out of those, the sepal length has to be greater than 5. This is the end of the data frames video. In the next video, we're going to be talking about if and for statements.